Carbon is an element which is of immense significance to us in both its elemental form and in the combined form. Carbon is found in the atmosphere, inside the Earth's crust, and in all living organisms. It is present in fuels like wood, coal, charcoal, coke, petroleum, natural gas, biogas, etc. Carbon is also present in compounds like carbonates, hydrogen carbonates, etc. and is found in the free state as diamond, graphite, fullerenes, etc. and these are known as the crystalline allotropes of carbon. The atomic number of carbon is 6. So its electronic arrangement is 2, 4, which means it has 4 valence electrons. Therefore, it can attain stability either by gaining 4 electrons or by losing 4 electrons or by sharing 4 electrons with other atoms. It does not gain 4 electrons because it is difficult for the 6 protons to hold 10 electrons. It does not lose 4 electrons because it needs a large amount of energy to lose 4 electrons. So what does it do? It shares 4 electrons with other atoms to attain stability, resulting in the formation of covalent bonds. Since carbon atom needs 4 electrons to attain stability, its valency is 4. That is, we call it as tetravalent. Like I mentioned, a covalent bond is a chemical bond formed by the sharing of electrons between atoms. The sharing of one pair of electrons results in the formation of a single covalent bond. Sharing of two pairs of electrons results in the formation of a double covalent bond. And sharing of 3 pairs of electrons results in the formation of a triple covalent bond. Now let's see the electron dot structures of some simple molecules formed by the sharing of electrons. For example, consider hydrogen atom. It has the atomic number 1. Hence, hydrogen has 1 electron in its K shell and it requires 1 more electron to fill the K shell. So, 2 hydrogen atoms share their electrons to form a molecule of hydrogen, H2. Now, this allows each hydrogen atom to attain the electronic configuration of the nearest noble gas. The numbers of carbon compounds whose formulae are known to chemists was recently estimated to be about 3 million. This outnumbers by a large margin the compounds formed by all other elements put together. Why is it that this property is seen in carbon and no other element? This is because the nature of the covalent bond enables carbon to form a large number of compounds. Two factors noticed in the case of carbon are, first one, that carbon atom can form bonds with other carbon atoms to form long chains, branches and closed rings. This property is called catenation. No other element exhibits the property of catenation to the extent seen in carbon compounds. Secondly, since the valency of carbon is 4, it can form 4 bonds with other carbon atoms or with atoms of other elements like hydrogen, oxygen, nitrogen, halogens, etc. The two characteristic features seen in carbon, that is tetravalency and catenation, put together give rise to a large number of compounds, and such carbon compounds are generally called as organic compounds. Now, carbon compounds formed by the combination of just carbon and hydrogen are called as hydrocarbons. And the hydrocarbons are of two types. We have saturated and unsaturated hydrocarbons. Saturated hydrocarbons are hydrocarbons having all single covalent bonds between the carbon atoms. For example, alkanes, they have all single covalent bonds between the carbon atoms and their names end with ane. Whereas unsaturated hydrocarbons are hydrocarbons having a double or triple covalent bond between two carbon atoms. Examples are alkenes and alkynes. Alkenes have a double covalent bond between two carbon atoms and their names end with ene, whereas alkynes have a triple covalent bond between two carbon atoms and their names end with ine. Did you know that carbon compounds can exhibit isomerism? Compounds having the same molecular formula but different structural formulae are called isomers, and this property is called as isomerism. And carbon compounds have the ability to exhibit isomerism. For example, butane, which is C4H10, has two isomers. They are normal butane and isobutane. Similarly, take pentane, C5H12, has three isomers. They are normal pentane, isopentane, and neopentane. So, now let's summarize this section. Carbon is a very unique element showing unique properties like catenation, tetravalency, and electronegativity. The different types of hydrocarbons are saturated and unsaturated hydrocarbons. What are saturated hydrocarbons? They are hydrocarbons having all single covalent bonds between the carbon atoms. So what is unsaturated hydrocarbons? They are hydrocarbons having a double or a triple covalent bond between two carbon atoms. Carbon compounds can also exhibit isomerism, that is, they can have the same molecular formula but different structural formulae.